Good morning, everyone. Today we are going to start with the next unit, that is fourth unit, principles of that is analysis of beams 1. So in this, what is meant by analysis of beams? You have to analyze the beam. For that you have to get the shear force diagram and bending moment diagram. So here, first thing, we have to classify the things into two types. There are two types of beams. One is called as unit. So this is unit for analysis of beams 1. So in this we are going to see, first topic is types of beams and their classifications. Broadly, beams are classified into two types. They are called as determinate beams. Another one is indeterminate beams. So in this case, how we can find out it is determinate or indeterminate? So there is a simple equation, that is total number of reactions in the beam minus total number of equilibrium equations. This is total number of equations, that is number of unknowns. This is number of equilibrium equations. So this is the formula. If this case it is less than, that is equal to 0, that is total capital R is equal to small r, then it is called as determinate beams. If this value have a positive value, that is greater than 0, then it is called as indeterminate beams. In some conditions, that is r minus r will be less than 0, that is negative value, it is called as unstable beams. So already you have studied about the determinate beams. Example for determinate beams are cantilever beam, simply supported, then overhanging. These are the types of beams which have determinate structure. Then some examples for indeterminate: fixed beam, continuous beam, and then propped cantilever. So this is an example for indeterminate beams, that is r minus r value is greater than 0. Okay, so how the fixed beam will be? Both ends are fixed. This is called as fixed beam. Continuous beam, you will have several number of hinged supports in between a long beam. You will have n number of supports. Propped cantilever, it is a cantilever with a support at the free end. It is called as propped cantilever. This is propped cantilever, this is continuous, and this is fixed. So we are going to analyze these structures. You know that it is easy to analyze the determinate structure as the total unknown forces. This is the total unknown force is exactly equal to the total number of equilibrium equations. So if you have 3 equilibrium equation, you will have at least 3 unknown reactions. So with 3 equation you can solve the 3 unknowns. But in this case, r value is greater than small r. If equilibrium equation is 3, then capital R will be 4, 5, 6, etc. So how to find out these things? For fixed beam, let's see what is R. So total reaction force is 6, that is 3 here and 3 here. So totally capital R is 6 minus small r. Small r is the equilibrium equation. So equilibrium equation is totally 3. So you have 3 redundancy. So this number is called as redundancy, that is extra unknown forces we have to find out. Then for this continuous beam, it have four reactions. So you will have 4 minus equilibrium equation is here 2. Why 2? You have summation of moment equal to 0, one equation, and summation of vertical forces equal to 0. You does not have any horizontal forces. So since that equation is ruled out, so 4 minus 2 here it will be 2. So in case if it is a hinged support here, you will have 2 reaction forces here, and you will get, then the equilibrium equation is 3 here, and total reaction is 5. So 5 minus 3, it is 2. There are extra 2 unknowns, so 2 redundancy. Then for this propped cantilever, here support reaction is 3 reactions, and here 1 reaction, so totally 4 minus equilibrium equation 3, so you will have extra 1. So these are the types of beams you will going to analyze in this chapters in unit 4 and unit 5. So in unit 4 you are going to use one method which is called as principles of superposition, and another one is called as 3 moment equation. 3 moment equation. So you are going to see principles of superposition and 3 moment equation. So let's start with principles of superposition. So what is simple principles of superposition? In the name itself it is there. You already have learned in the physics, if 2 waves are there, if you are adding 2 waves, if the crust is added with crust, it will get doubled. So this is, if its value is A, if its value is B, so this total value will be A plus B. So similarly here C, D, and here C plus D. So this is called as principles of superposition. But in the same case, if the wave is like this, then here this position and this position A, here it is B, here it is C, here it is D. So total value here it will be get 0 and 0, because A is positive and B is negative. Here C is negative and D is positive. So you will get A minus B, and here C minus D. If C is equal to D, it will become 0, and A is equal to B, it will become 0. So this is called as principles of superposition. So similarly, for example, if a cantilever beam, if it is having different loads on the same beam, say here 2 point loads, and you have UDL here and another UDL here. Here it is W1, W2, capital W1, capital W2. So to analyze this, you can separate each loads. So take first W1, then W2, then W3, then W4. So 1, 2, 3 and 4. Take each separate forces and find out the deflection or the slope at any point. So if I am going to take this slope or and deflection at the end. So at this end, you can first apply only the W1 and find the deflection, that is delta 1. Then apply W2 and then find the deflection delta 2. Then W3, so with the W1 it is delta 3, and then with W2 it is delta 4. So after finding all this, you have to add everything. If delta 1 is downward direction, delta 2 will be downward direction, this is also downward, and this is also downward, all in the same direction. So you have to add everything, and you will get total deflection is equal to delta 1 plus delta 2 plus delta 3 plus delta 4. So this is called as principles of superposition. So similarly, if you separate, I am going to consider this fixed beam. So in this fixed beam, you can see that if you draw in the free body diagram, it is horizontal force, vertical force, moments. So this is the free body diagram. So yeah, we are replacing the fixed support into the forces and moments. So here it is, if it is B and A, it is HB, it is HA, and here it is VA, this is VB, and this is MA, and this is MB. So you can see that these are the forces. So here how the principles of superposition works. So first I'm going to remove this MA and MB, which is I don't know and I have to calculate it. So now the balance is, you can see that here it is VA, VB, HA and HB. So these are the only forces. So with this I will find, if there is a load, vertical load, say W, then it will have a bending moment diagram like this. And after that we are going to add this MA and MB. So here MA is, it is clockwise direction, that too in left side. So left side clockwise direction is positive, and here it is anti-clockwise in the right side, so it is positive. So both are both are negative values. It is clockwise in left side is negative, and anti-clockwise in the right side is negative. So both MA MB will be in negative direction. So here it is in negative, it is in negative. Maybe in this case it is similar, so MA and MB will be in same values. So here we have to set that this negative value will be downward direction. So with this reference we have to overlap these two things. You can see that this is bending moment due to only the force, and here MA MB it is due to, and it will be in negative direction. So this is MA and this is MB. So we have to add these both the twos. So this is the reference line here. Here it is reference line. So these two things we have to overlap, so that you can see that the diagram will be like this. So this is the final bending moment diagram. So here this, now in this case this will be the reference line. So this is plus, this is minus, and this is minus. So you can see that at the support reaction it is negative bending moment, and at the center it is positive bending moment, that is sagging bending moment. You can see that this type of beam will bend like this due to the point load W, due to the point load W. So this is called as principles of superposition. You have to calculate everything separately and finally add. So little bit advantages of this method is called as three moment equation. Three moment equation. Let's see in the next lecture. Thank you.